Hello, everyone. How you guys doing? Did you have good lunch? Are you having a good reInvent yet? Good. All right, my name is Raj Koparapu. I'm a senior product manager on the key management service team here at AWS, and I'm here to welcome you to reInvent and the topic SEC337, Toyota Motor North America, securing the cloud with AWS KMS. AWS people talking about their products and services was one thing, but now customers coming up and saying how they use the products and services to secure their infrastructure and to do what they need to do as far as working with their workloads is a different story. And that is what I'm more excited about today, because I have a customer here wanting to talk about what they've done with AWS KMS and AWS in general, right? So today I'm very excited to introduce to you Kel Rossman from Toyota Motor North America. He's a senior manager of security software engineering. And hey, Kel. And Matt Costello from Booz Allen Hamilton. He's a principal at Booz, and he manages the commercial analytics practice at Booz. So security is something that I've been in the field for a couple of years now. And the way I look at it is a good security program does three things, right? So first is prevention. Stop the bad things from happening in the first place. Second, you continuously monitor your environment so that there's no inadvertent exposure of data. And then third, just in case, if something were to happen, you have means to actually react to any of those incidents, right? So those are the three tenets of a good security program. So while we were contemplating what sort of a talk would be beneficial for an audience like yourself, I approached Toyota as I've seen what they've done with AWS KMS, and I was very excited when Kel agreed to come up on stage and share their story and inspire you to know how they secure their infrastructure, right? What they've done is they've built in continuous monitoring to be able to analyze billions of messages that come in from their connected vehicles, and how they've secured those billions of messages using encryption is something that they will talk about, right? So one of the big things is encryption is a way for you to allow permission and access to critical data only to people that you would like that access to be granted, right? So in AWS, you have identity and access management that gives you policies that lets you do that. But KMS gives you this additional control over IAM to be able to do more access control of that encrypted data, right? So today, what Kel and Matt will be able to do here is to talk about their analytics, security analytics platform that they've built on AWS and how they've used that to secure their platform and infrastructure and all of the data that they get from their customers and vehicles, right? So again, going back to what I was saying, a good security program will have the preventive measures and the continuous monitoring, and in today's talk, we will see the continuous monitoring and the preventive actions that Toyota has taken along with assistance from Booz Allen to be able to build this analytics platform in AWS, right? So Toyota is in the business of building great cars and trucks, and they take their customer data and their customer safety very seriously. And I'm pretty sure all of you guys here in this audience are also very diligent about treating your customer data. So I'm very excited for them to share their story and inspire you of how they've managed to use KMS to secure their infrastructure. And I'm pretty sure this session will be valuable enough for you to take away things that you can do in your own AWS environments. With that, Kel.
Thank you. So I'm very excited to be able to present on behalf of Toyota. to talk about how we secure both our enterprise, the connected vehicles, our manufacturing apps, and how we secure both all of those with our security analytics platform, but really dive into the infrastructure and how that's protected. So to kind of kick off, I wanted to explain the challenge, the Toyota challenge. As we go through digital transformation, our vehicles become more connected. That means the enterprise apps, the manufacturing environments, as well as the vehicles are now all connected. And so I want to, and not only do we do that here regionally, we also do it globally. And so how do we protect the vehicles, but then also all of our supply chain partners? Next, I want to talk about the architecture and really kind of explain how this platform was built using a lot of the AWS cloud native services. We really leveraged a lot of what AWS has to offer to really help reduce the overhead and management. And so I want to dive into a lot of that. Next, we'll go into the data flow. We'll look at how the data comes through the platform and how we use KMS to encrypt and decrypt and how we handle the billions of messages we get per day, especially as we have over 1 million vehicles currently, connected vehicles out on the market, and as that continues to grow over time. We'll also dive into a use case and kind of show you the value and how we're able to really leverage KMS to keep the data secure, but also do the analytics very quickly so we can get the relevant data, but do it in a secure manner at scale. And then finally, we'll dive into some of the details and really kind of explain the novel way we've applied KMS and how it interacts with IAM, and how we're able to lock it down so that analysts are only able to view the data they need to do their job, but then system admins who build the infrastructure, they're not able to see the data. They're allowed to build the infrastructure, an immutable infrastructure. So that way, and then how we instrument it and to make sure that nobody can unauthorized access. So kind of setting the stage, the issue we have is as the digital transformation is underway, we're having to connect our enterprise apps to be able to buy cars online. That now is connected to the manufacturing sites. If you want the vehicles, they also have telematics, and they send data back to the enterprise app. So now you have this whole ecosystem that's connected that traditionally was not connected. And not only that, a lot of these vehicles and enterprise apps, everything is global. So we have global suppliers that we have to interact with, and they have data that they share, and we have we also have a lot of their products as well. So we have this massive ecosystem that's now being connected. And how do we monitor this from a security perspective? And so from a scale perspective, we had this global problem. Even though we're focused more on North America, it is a global challenge. And we were able to partner with Booz Allen to help us build a cloud-native AWS solution. And kind of the key piece to a lot of this is, okay, that's great. We have a security analytics platform that can detect and monitor and use automation and be able to find the anomaly and be able to react to it quickly. But how do you lock down your data? Because that's a wealth of information people want to, hackers would want to go after, or if something bad were to happen. That's the kind of stuff we wanted to make sure that was completely safe and lock it down and try to inspire the trust, because Toyota is big on safety. We treat cybersecurity as a safety issue. So we feel, this as we go into the digital realm, we're trying to transform it, and we want people to understand that we take this very seriously and it's very well controlled. And so, So first, there was kind of 5 pillars for this project that I worked with the team and said, this is what we have to do and have to enhance our current operations. The first one was we needed to be able to have robust data pipelines that would go around the world. We needed to be able to pull in different affiliates, different suppliers that are located all over the world. That meant that data was coming from on-premise, data would be coming from cloud, multi-cloud, as well as through other affiliates within Toyota. So there's different levels of maturity, and so we needed a common template that when we deploy this out, you could have the least mature organization to be able to deploy it quickly within under an hour. Second one, and this is kind of the main key piece, is we wanted to make sure that this was secure. It had to be secure. There was no ifs, ands, or buts. Plus, it's a security platform. If we don't do our job, nobody else will. So the main thing here is we followed all of the best security engineering practices with least privilege, and a lot of this we'll dive into later to explain it. But we follow least privilege. We segregate everything. So if there was an issue, we limit exposure. We have over 200 plus alarms that look for any anomalous events. We have automation in place that auto responds. So if we do find something anomalous, actions are already taken to try to correct it. The next one is we already had security operations. So as this upgrade was going on to help handle this new connected future, we had to make sure that our existing feeds were still working, and we couldn't have any kind of interruption. And so the other thing too is we needed to make sure that there was able to support any kind of operational issues. So we had to balance the feed, and this is where AWS Cloud Native tools really come in, because it is PaaS. It handles kind of all the overhead features, so we could really focus on more of what we believe was the value-added piece to get this platform up and running and making it secure. And then one of the last items is migrate. We had existing dashboards and analytics and all kinds of fun AI, ML type stuff, and we wanted to migrate that to AWS. And so we did a lot of trade studies to make sure we were leveraging AWS fully and how to best do it. And then finally, being able to support security incidences as they occur. We actually had several security incidences during this time, and we were really able to kind of refine and prove out this technology. And what was amazing to me through this and really kind of validated our architecture approach and then just AWS tools and the power they have is we were able to deploy in under an hour into a whole new environment across the world. And it actually took longer to have the meetings to discuss how we wanted to do this than it was to actually deploy the script. So that to me just showed you, and we'll dive into some of those details and how we template that out. But to me, these were the 5 challenges that we had to make sure we met, and we really knocked it out of the park with this, thanks to Booz Allen with their help on it. And so looking at this globally, we have manufacturing sites all over the world. We have enterprise apps that are all over the world, cars that are all over the world, because Toyota North America cars, if they get shipped overseas or if they go across borders, there's different encryption regulations and things of that nature. So we really, even if it is here in North America, it really is still a global problem. And so we have to kind of solve that globally. And so the main takeaway here with the global event is that we have to deploy around the world. If there's an incident somewhere around the world, we have to be able to deploy our environment to collect the logs, to be able to do the analysis and the investigations, and really leverage kind of the AWS's global infrastructure. And that really allows us to scale, because a lot of what we build in North America gets rolled out across the world. And so this leveraging AWS's Cloud Native does this all in the back end. I don't have to sit there and set up stuff. I don't have to spool up anything. I just say, hey, I want this region, deploy my scripts, off we go. And so looking at the architecture overview, I kind of want to spend a little time here to go through each of the little pieces to explain it. But on the right, you can see kind of the highlights. We've highly instrumented this environment. We know exactly when data goes down. We know how much data the throughput's going through. We have full visibility from end to end, from the time the data source comes to us to the time it's an analytic or into our platform. We do over 2.7 billion records per day, and these are all encrypted. So the keys we're hitting KMS quite a bit. And it's able to do this at scale, and we don't have any performance degradation. We're also, we're doing this globally. As you can see here, we have quite a few data sources that we've ingested in. Like I mentioned, it takes about under an hour to deploy a lot of these features and a lot of the additions. It often takes longer to just have the meeting to discuss what we're trying to do, just because we leverage a lot of automation within AWS. And so kind of the first piece is, we deploy out, there's different levels of maturity in different parts of the organization, and so we try to make it as easy as possible for that organization to be able to deploy our environment. And so we leverage Amazon's managed streaming for Kafka, and this really allows us to, we don't have to have a lot of knowledge per se into their environment. We just need a way for them to point their collectors to our environment. And this really allows us to not abstract out that back end, kind of the infrastructure, and deploy it around the world globally. Next, we have kind of bridge. And so we do an EC2 incidence where we send syslog as well as being able to manage the pipeline from Kafka to the data firehose. And really, all we're doing here is we're building out just your kind of best practice AWS data lake. But the key piece is really gets into the encrypted data side. This is when the data comes into the environment, we encrypt it right away. And so we actually have, and I'm going to go build this out, is we actually have the data comes into encrypted. And so it goes into the first simple S3 bucket, and it has its own unique key. The AWS Glue job has a separate key as well. So the data is encrypted at rest, it's encrypted in transit, and as well as each Glue job does exactly the transformation it needs to, and it uses the key to encrypt and decrypt and encrypt back. And then when the data is stored, it's a different key. So we have multiple keys being used, so then that way if one key is compromised, the splash damage is minimized. And so again, it's following the principles of least privilege. And we do this, we have several tiers to it. So the first tier is we just dump the raw data into it, and we have that available. So if we ever need to go back and do some sort of an analytics, we can. The next tier is we groom the data a bit to kind of start normalizing it. And then the third tier is when it's fully normalized and we use Athena on top of it, so we're able to query across the data set. And so we use multiple keys here in order to help ensure that the data is secure, as well as it's in leveraging AWS KMS allows us to be able to manage that all kind of behind the scenes without any kind of performance impact. And all of these keys are separated from an IAM role. So if you were to access the environment with, say, like a system admin role, you would not have access to the KMS keys to be able to provision the key needed to be able to encrypt or decrypt the data, to decrypt the data. You would have to have the right IAM role with the right KMS key pairing. And so we'll go into a little bit more of that in detail, but this allows us to really take all of the data, encrypt at rest, in transit, and really limit the availability of who can access what and how it can be accessed. So, and it gives us a lot more granularity and allows us to do this at a global scale. And so with that, I'm going to hand it over to Matt to go into the details.
Thanks, Kel. So as you saw from the previous slide, this is a fairly complex architecture. There's a lot of moving parts in it, a lot of pieces that need to be configured. And so one of the design choices that we made very early on was to template all of the orchestration for building all of the different components. This was one of those key tenets that Kel talked about around being very able to react very quickly and to stand up new infrastructure very rapidly. In a security setting, you don't always have insight, you don't have advanced warning when you may need to very quickly pick up a new data source or help out an affiliate with an issue they're having. And so the ability to scale very rapidly and deploy very quickly was a critical feature. This gives us some consistency around our output, obviously, over doing things manually, better version control, all of those terraform scripts and things can be in version control. It also gives us a great option for DR because we can replicate our data to another region and then simply use those terraform scripts to stand up the corresponding infrastructure in the event of an issue of some sort. So to do all of this, we started out with about 500 different Terraform templates, believe it or not, covering analytics, so setting up the glue crawlers, the glue databases, the ETL jobs, and the triggers. On the security side, setting up the IAM roles, the VPC security groups, the customer managed keys, alarming, and Lambda secrets, where we use Lambda to integrate with third parties, and we'll talk about that a little bit. Also, obviously, encrypting the buckets themselves, and then any EBS volumes that we need. And then finally, the fire hose, which at this point we're somewhere between 150 and 200 fire hoses for the various different sources that we collect. So the way that process works is that we start out on the left with the fire hose collecting data from one of those regions or one of those on-premise data centers. So this could be in the United States. This could be South America, Asia, wherever. It lands in an S3 bucket in a landing zone layer. And the landing zone layer is basically just where we write out the raw data and we have it for long-term storage. So this sort of gets processed quickly and then immediately moved to cold storage to reduce storage costs. Certain types of data that we collect may only land in this layer. Like, by that I mean if there is data that we collect because there's a regulatory reason we need to keep it, but it's not something that's actively monitored as part of a security operation, then we may simply store it there and have it for however long the retention requires. As Kel mentioned, each bucket is encrypted with its own key, and then each glue job has its own key as well, so that it decrypts the data, does the transformation from a landing zone to a parse layer, and these are pretty standard steps for any sort of data enrichment environment. Getting it into a transform layer where it's purpose-built. So we start with raw data. This could be syslog, this could be CAN bus data from an automobile, this could be firewall logs, endpoint logs, Office 365 logs, whatever it might be. Those land in that first bucket, and then the first thing we do when necessary, if it doesn't come through in JSON or some other easy-to-read format, is we'll parse it and put it into a readable format for Athena. And that's what that middle bucket does. At that point, we can start to look at those logs, mine those logs, look for anomaly behavior, other types of things immediately, but there are also certain specific use cases where we have specific analytics that we build. And these are sort of purpose-built tables to drive a particular dashboard or a particular ML job or whatever it might be. And so that's what that transform layer does, is it basically stores the data in an insight-ready format so that you can then look at it in Athena or render it in QuickSight as a dashboard. As an example of one use case that we put together for Toyota, many large enterprises, Toyota included, have a very large footprint, as you've heard. Lots of devices spread all over the globe, and lots of systems keeping track of those devices. So you have SCCM and tools like that keep track of Windows assets. You have endpoint logs, you have scanners, you have DHCP, which is going to tell you about all your dynamically addressed items. Other CMDB logs for different types of asset listings. Maybe something in like a ServiceNow, that type of tool as well. The challenge for the security organization is that it needs to be in one place, and you need to have one list. You can't secure things you don't know about, and so until you have a very comprehensive list of all your inventory, it's very difficult for you to lock it down, make sure it's properly patched, make sure all of the security stack is on it, and make sure that it's properly secured. So what we did is instead we took all of those different data sources, ran them through a process that was built using glue jobs to basically combine them into sort of a superset. So we took every scanner tool that was in use, combined the output of all of them, and came up with sort of a master list of all the assets, along with here's the last time it was patched, here's the last time it was reported by this tool, by another tool, and so on. This gives Toyota basically a very accurate picture of their inventory, and not just what they have, but also its health. When was the last time their endpoint tool reported a particular item? When was the last time it was scanned? What's the last patch level it had? And so this crosses Linux, this crosses Windows hosts, this crosses cloud assets, so whether it's EC2 instances or other tools running in the cloud, all in one place. And so you can see that little sample in the bottom right there. That's a QuickSight dashboard that we built. That basically just shows you how many assets they have, patched, unpatched, Windows, Linux, and so on. And then they can use that information to better secure their environment. So again, as Kel mentioned, security is one of the key drivers in terms of how we store the data, how we think about moving the data around, and ultimately, as he mentioned, being the security group at Toyota, you have to sort of lead the way, right? So you got to kind of set the example. So we use layers of security in this architecture, starting with encryption at the very bottom layer, so at rest, using either KMS keys, policies, On top of that, we have system level security, so where we use EC2 instances, which is very minimal, or other images, and then encrypted volumes for those images. Next, we have network security groups, which control access to the objects, and VPC groups and flow logs to tell us what's happening. And then finally, access control, like S3 bucket policies, IAM policies. As Kel mentioned, we always have 2 layers of security on any given object. You have an IAM role, which gives you access to that object, and you have a key, which allows you to decrypt the contents of that object. So you need both of those in order to access any data. And then finally, monitoring on top of it. So this is going to be CloudTrail, GuardDuty, tools like that, CloudWatch, that are monitoring all of the moving parts in this architecture, alerting us when there's a problem. Tools like GuardDuty even alerting us when there's anomalous behavior around accessing the data itself. So as we talked about the layers of security, it starts at the most granular level with bucket policy. You then have KMS policies, which leverage IAM to limit access. You have limited ARNs and actions in the IAM policy, and then finally, the IAM role, which is controlling access to the service itself. When we stood this up, there are a couple of, and you saw this a little bit on the slide that Kel talked about, there's a couple of different ways that we get data into the lake. And again, this was part of that flexibility requirement that we sort of talked about at the beginning. So one of the easy ways is we have existing cloud services running in AWS, coming through CloudTrail, CloudWatch and CloudTrail, that go through a fire hose or just directly into an S3 bucket. Amazon provides a Kinesis data fire hose, which will automatically push to a Splunk HTTP event collector, and that's what that blue box is with the circles. So the security organization at Toyota is pretty heavily reliant on Splunk. They like it a lot, and it works very well for the use cases they use it for. So that was an absolute requirement when we talked about some of those constraints. We needed to make sure that we continue to support Splunk going forward. One of the nice things about the Amazon Firehose for Splunk is that it will put a copy of the data in a bucket for you as well. So you kind of get 2 for 1 on those fire hoses because it'll push it to Splunk and also drop it into S3 where we can use it. For certain types of data sources where we're pulling from either a REST service or something along those lines, we'll use Lambda functions to do that. So good examples of that might be access logs for Office 365 and OneDrive and tools like that. Other types of SaaS providers like ServiceNow or Workday, tools like that where you need to call a REST API to get the logins, the logouts, the privileged access logs, some of those things. So Lambdas are a great way to do that at a very low cost. They go up very quickly. They scale as needed, and so those will flow through as well. In certain cases, we'll also put Kinesis agents where appropriate on different devices and have them forward logs directly. Probably what you're starting to sense here is it's not one tool, it's a bunch of tools that gives us the flexibility to handle lots of different situations. In cases where we have syslog type data, so these are things like firewalls and Linux hosts and those types of things, we'll use a tool like syslog-ng or something like that to collect the syslog data and then forward it to Kinesis or to Kafka, as the case may be. The Kafka bridge is the piece of code that takes from either MSK or on-premise Kafka and pushes it into the firehose. So if I back up a little bit, when we have, there's a couple of very large data centers that Toyota has in North America that have thousands upon thousands of hosts in them. And they're all generating logs all day long, and you need a way to collect those reliably and push them to the cloud, but also have a certain amount of sort of back pressure relief. So it can store it, and then it can forward it, and if there's an issue with connectivity or there's an issue with misconfiguration in AWS, if there's any sort of unforeseen problem, you always have that Kafka cluster on-prem to go back to get your logs for a period of days. So to get Kafka and Kinesis don't directly talk to each other, so what we did in this case is we used some bridge code that we took from AWS actually, and then we modified it to pull from multiple topics in multiple Kafka clusters and be able to push into multiple fire hoses. So what that gives us is a global reach. We can pull from Kafka running in the cloud in, say, South America for those affiliates. We can pull from Kafka running in a data center in North America where we have a very high volume. And then it all comes through that bridge code and flows into Firehose and then follows the normal path. One of the key drivers of this architecture was that we needed to be able to stand up new data sources very quickly. So once we have the Kafka infrastructure in place, we can stand up a new data source in 30 minutes or less generally to move data if we have an affiliate that maybe turns up a new proxy or turns up a new firewall. It's very quick to turn those on. I talked about the Lambdas a little bit. Those are usually, at least in our model, used mostly for cloud services and REST services. So to encrypt the data pipeline, we have a unique key for every fire hose, and there's somewhere between 150 and 200 fire hoses right now based on the different data sources we have flowing from all the different spots around the world. There's also obviously a key on each bucket, and so by using different keys between the two, we can allow for very granular access to data within a shared bucket. So we can control what the fire hose can write to and then also who can read it. Same goes for Athena. Athena uses KMS keys to permit a role to access the data catalog. The keys can also limit the tables that can be accessed in Athena. Remember that Athena has a glue data catalog as part of that it uses to understand the data sources. And there's a series of crawlers that back that up that are rescanning your data at regular intervals to let you know about new data sources that have appeared. Learn security with AWS training and certification. So, can't say enough about how important this is. And I think
That was all.
that was it.
I think that was it, yeah.